I'm going to briefly demonstrate how to use an interactive simulation that compares adiabatic compressors or adiabatic turbines that have different efficiencies. The simulation used air as the flowing gas and assumed to be ideal gas. And we can make a comparison either constant outlet pressure, the same outlet pressure. So let's look at this, what the simulation looks like. So we can compare the same pressure, in this case 15 bar, for different efficiencies. In this case, the efficiency is 1, so reversible compressor, and here efficiency is 0.7. We can also compare at the same outlet temperature. So note that the more common standard way of making comparison is at the same outlet pressure. And we can pick which pressure we want to use. So for example, here we're going from 2 bar to 15 bar. In the reversible case, efficiency of 1, the outlet temperature is 534, whereas here the outlet temperature, where the efficiency is only 0.7, is 634. It's hotter because we had to put more work in, and all that work goes into in the energy balance into raising the temperature for an ideal gas. So significantly higher temperature, significantly more work. So let's look at the interactive simulation. So here is the simulation, and we can, for example, select turbine and compare, say, efficiency 0.7 with the efficiency of 1 reversible. So we compare to the same outlet pressure, and turbine's doing work. So we get a lot more work out of the reversible, and as a result, the outlet temperature is lower since the energy balance, the work is equal to the heat capacity, number of moles per time, or the number of moles in this case, and the temperature difference. So we get more work out with lower final temperature. It's more efficient. We likewise could make the comparison at the same outlet temperature. And now what happens is the turbine outlet pressure is higher. We had to lower the pressure much more for the irreversible turbine, efficiency less than 1, in order to get the same amount of work out. We get the same amount of work out because we're at the same temperature, and the work is directly proportional to that temperature change. So this is a useful way to get an idea of how efficiency affects the outlet conditions for turbines and compressors.